Lesson 10.6, video part 1 of 2, I believe. Key terms here is similar triangles. Triangles that have the same shape, but not necessarily the same size. Case in point being down below. The same shape can occur if you have the same angles. Okay, so it says corresponding angles are equal in measure. Corresponding means same place, different triangle. So bottom left-hand corner, both 60 degrees. Bottom right-hand corner, 48, bottom right-hand corner, 48. Those are corresponding angles. And then top and top. Those angles are the same, which makes these two shapes similar. They're not exactly the same shape in terms of size, but they are similar. And that allows us to create proportions. Now, there's a couple key things we want to emphasize here, and that is that when you have similar shapes, you can make a similarity statement. And notice that in doing so, A matches up with D, which we said they are corresponding. B matches up with E, and then C matches up with F. The corresponding angles match up in the order in which they put the letters down. And also, it allows us to make proportions, and that's our biggest tool here. So notice that ABC and DEF, I can make a proportion relating side AB and side DE. That's right here. And then I can make a proportion that relates BC and EF. That's right here. And then lastly, I can go A and C and D and F. So I'm just putting the sides together, and you can make proportions. Now, when we solve problems and exercises, we really only focus on 2 at a time. And then we would cross multiply to solve. So let's see if we can take a look at a couple things here to decide if things are similar. Now, in example 1, this is really a geometry problem. And we can decide that these are similar based on geometry. Because if you have this shape and you have parallel lines, then this CQ right here and BP, those create sorry about that, now I got it fixed. Those create transversals. That means that this angle here is going to be equal to this angle here. And this angle here, I'll put two arches to show that those are the same. And you can also say that these two angles are equal because they are vertical angles. And that's more geometry, but when we do these kinds of questions, and these are called really bow tie questions because it looks like a bow tie, we have to relate corresponding sides in a different way. We wouldn't want to say C goes to P. We'd want to say B and P are corresponding angles, and they would match up. So this is indeed similar. And if I were to write a similar statement, I would say triangle RBC, so RBC is similar to triangle. I have to match it up here, so R would go with R, B goes with P, and then Q goes with C. And we know that based on the angles that we see. So these are definitely similar. On the next one, here we want to look at it in terms of 2 different triangles. That would help us best by saying that I have this triangle, and that triangle I'm going to draw separately, and I have 25, and I have 20. Then my other triangle will be this one, the bigger one, and that is side 44, side 66, and all of this together gives you the third side, which is 55. Now, if they are proportional, I can make a ratio, and it'll be true. So I'm going to put corresponding sides together now instead of angles. I'm looking at sides. So 20 and 44 go together. They're corresponding sides, and that should equal, I'm going to put these two sides together. Now notice I'm going left to right, and that order matters because I have to do left to right for both of my fractions. If I cross multiply, I should get the same thing. So 44 times 25, does that equal 20 times 55? And if you calculate that out, you actually get 2,750 and 1650. They are not equal, so no. And this ends part 1 video.